Hello students, welcome. Previously, lesson 17 from 4 to big 4, we were dealing with applications of electrolysis, and we have done the first 4 applications of electrolysis. The first one was extraction of reactive elements, the second was electroplating, the third one we were dealing with the sacrificial protection, and the fourth one we were dealing with purification or refining of metals. So today, lesson 18, we want to proceed to the fifth application of electrolysis, that is manufacture of sodium hydroxide, chlorine gas, and hydrogen gas. So we're saying sodium hydroxide, chlorine, and hydrogen are manufactured by electrolysis of brine using the mercury cell. Remember, brine is concentrated sodium chloride. So if we are going to manufacture sodium hydroxide, chlorine, and hydrogen using electrolysis of brine, we are supposed to have 3 things. One, we are supposed to have the electrolytic cell. In our case, we are going to have the mercury cell or mercury cathode cell. So number 2, we are supposed to have the electrolyte, and we are told the electrolyte in the mercury cell is a concentrated sodium chloride solution, which is also known as brine. So next again, we are supposed to have the 2 solids that are dipped into the electrolyte during electrolysis, and we are saying we are having the anode and also the cathode. So what is the anode made up of, and what is the cathode made up of? That's the next thing that we are supposed to know. We are saying the anode in the mercury cell is made up of carbon or titanium. Remember, both carbon or graphite or titanium were just inert electrodes. So we said inert electrodes are electrodes that does not react with the product formed at the electrodes. So we're saying here, the reason why we are using the anode made of carbon or titanium is that because they do not react with chlorine gas produced at the anode. So that means they are not going to react with the product formed at the electrode, which is chlorine gas. What about the cathode? We are saying the cathode is made up of a moving film of mercury or flowing mercury. So this is how the mercury cell look like. So this is how the mercury cell look like. We are supposed to have our concentrated sodium chloride solution or brine in here. Then this is our anode, which is made up of graphite or titanium. We have seen the reason why the anode made of graphite or titanium. So here is where we are going to have chlorine gas out. So that means chlorine gas is produced at the anode. So next here is where we are going to have water in or distilled water in, and all here is what we are going to have the mercury cathode or the flowing mercury or film of mercury. So this is where we are going to obtain sodium hydroxide solution. So this is where hydrogen gas gets out of the cell. So next we are saying concentrated sodium chloride solution contains sodium ions, chloride ions from sodium chloride, hydrogen ions, and hydroxide ions from water. So what will happen when electric current is passed through the solution? We are told chloride ions and hydroxide ions, being negatively charged and ions, they will migrate towards the anode. We say the anode is the electrode which is connected to the positive terminal of the battery. So chloride ions and also hydroxide ions, being negatively charged and ions, they will be getting attracted towards the positive terminal of the battery, which is the anode. But the two, which one would be discharged at the anode? We are saying chloride ions are preferably discharged. And the reason why we are discharging chloride ions over hydroxide ions is due to their relatively high concentration compared to the hydroxide ions. So next we are supposed to have the reaction at the anode. Remember, we are having chloride ion which are discharged at the anode. They are going to lose 2 electrons to form chlorine gas. So that means the observation that we are going to make at the anode will be a green-yellow gas is observed. So next we are saying sodium ions and hydrogen ions, being positively charged, the cations, migrates to the cathode. What's the cathode? The cathode is the electrode which is connected to the negative terminal of the battery. So sodium ions and hydrogen ions, being positively charged cations, they will be moving towards the negative terminal of the battery, which is the cathode. So between them, which one will be preferentially discharged? So we're saying here hydrogen ions are not discharged. The reason why we are not discharging hydrogen is that we are told because of the overpotential or the excess power required to discharge it. That means to discharge hydrogen requires a lot of potentials. Therefore, we are told sodium ions are preferentially discharged instead. So that means we are going to have sodium ion which is discharged at the cathode, or where we are going to have the flowing mercury, or where we are having the moving film of mercury. So 2 of sodium ion aqueous gains the 2 electron lost from the anode to get 2 moles of liquid sodium. So thereafter, we are saying the sodium atoms formed dissolved in the hot mercury to form sodium amalgam, which is written NaHg. Remember, at the cathode, we were having mercury. Remember, mercury is an active electrode. So what is an active electrodes? Those are electrodes that reacts with the product formed at the electrode. Okay, so here we are having the sodium formed at the cathode reacting with the hot mercury to form sodium amalgam. So this equation is self-balanced like that. We proceed next. So next we are told the sodium amalgam is passed through a trough in the cell that contains distilled water. Then we are told the sodium in the sodium amalgam then reacts with water to form sodium hydroxide solution and hydrogen gas. Remember, learners, when a metal reacts with water, we form 2 products, metal hydroxide and also hydrogen gas. So if sodium reacts with water, we are going to get sodium hydroxide and also hydrogen gas. So we're told next hydrogen is bombed out to the required place. What does that mean? That means hydrogen is bombed out to maybe to a herbal process plant or to hydrochloric acid plant, while mercury is regenerated and recycled. So the question is here, sodium amalgam, 2 mole of sodium amalgam liquid will react with 2 moles of water, which is liquid, to form sodium hydroxide solution and also hydrogen gas. Remember, mercury is also regenerated. So what is the advantages of recycling mercury? We have 2 advantages. One, it lowers the cost of production since mercury is expensive. Number 2, it also minimizes pollution since mercury is poisonous. So from there we are going to go and see advantages of the mercury cell or the mercury cathode cell, and we are saying the sodium hydroxide obtained in the mercury cell is very pure. That's about 50%. So if you want to make or to increase the purity of that sodium hydroxide, we are told more pure sodium hydroxide is obtained by evaporating the water in the aqueous solution of sodium hydroxide to get pellets or flakes. So next we are going to go and see the advantages of mercury cell. One, we said it leads to pollution, reason since mercury is poisonous. Number 2, the other disadvantage that we have is mercury is expensive. So next we are going to go to the uses of sodium hydroxide. Remember, learners, we are dealing with the manufacture of sodium hydroxide, chlorine and hydrogen gas using the electrolysis of brine. So learners, you are supposed to know at least 4 uses of sodium hydroxide, 4 uses of hydrogen gas, and 4 uses of chlorine gas. So remember, hydrogen, uses of hydrogen, we have learned in the chemistry of water and hydrogen, chapter 5, form 1. The side of chlorine, the uses of chlorine, we have learned it in the chemistry of chlorinaceous compound, that is chapter 6 of form 3 syllabus. So uses of the sodium hydroxide, we are going to learn it here. Number 1, we are saying it's used in the manufacture of detergents. Number 2, it's used in the manufacture of glass. Number 3, we are told it's used in the extraction of aluminium from its ore, that is from bauxite ore. Number 4, it's used in the manufacture of bleaching agents. Then number 5, or lastly, we are saying it's used in paper industry for the manufacture of wood bulb. Lastly, we are going to go and see the extended questions. We have only one question there where it will state any 4 uses of the following gases. Part A, we are having hydrogen gas. Part B, we are having chlorine gas. That's the end of our class. Thank you for watching.